Okay, I'm going to talk very, very briefly about floating point support on ARM, except that I'm not quite talking about that. Maybe ARM hard FP support, or perhaps better, hard FP support in Fedora ARM. So that's what we'll go with. Two quick facts about ARM that inform what I'm talking about here. First off, moving FPU register content into CPU registers can incur a 20-cycle stall, so that's fairly expensive. The other problem is that not all ARM CPUs have floating point units, so this leads to an interesting dilemma. There's a couple of different variants of the ABI, and John is very precise in the way that he lays out these ABIs. He uses exactly the right acronym. The rest of the world just calls them hard FP and soft FP. Soft FP doesn't mean you can't use a floating point unit, but it means that when you call a function, you pass the parameters in the CPU registers because you're not confident that there's an FPU there. Hard FP, on the other hand, requires that FPU be present. You pass parameters in the floating point unit. Real-world difference in performance obviously depends on what you're doing, but definitely single-digit percent and perhaps low double-digit percent performance impact. Exciting thing though, ARMv7 guarantees the presence of a floating point unit. So finally, we're at the point where we can safely move to the hard FP ABI variant. In the Fedora context, and I'm coming at this from the Fedora ARM context, in the Fedora context, Fedora 15 seems to be a really good point to do this switch because we have the compiler support, we've got the languages and so forth that are going to work well with this. You cannot mix and match. Because the way that these two ABI variants work, you can't have libraries that are one and executables calling those libraries that are another, and vice versa. You've basically got to go all one way or all the other way. However, you can run them both under the same kernel. It's not kernel interfaces that we're affecting here, it's the ABI. So, our goal in Fedora ARM is to get up a Koji builder so we can build our RPMs. That involves a bunch of other pieces of the stack. So to get Koji running, we need mock, which is our change root build system, and to get that going, we need, in the sort of core of that, the RPM build piece. And of course, there's lots of other pieces that sort of back this and go with this, compilers and tools and so forth. Our goal here is, this again is for the F15 build, which we are about to head into. The thing to bear in mind is that this isn't the last port ever. We're going to encounter other ports, and we thought, let's try and do this in a way that will make the next task a little bit easier. Solution is a change root. Because we can use the same kernel, we can use a root environment with cross and borrowed tools. DJ from Red Hat in their, I only know is Ison. DJ Delory. Is he David?
No, his legal name is DJ.
Legal name is DJ. No wonder I don't know what DJ stands for. It's his legal name. Okay, I feel much better now. He's put together a primitive tool chain with some cross tools, I think a few borrowed tools, and I think Dennis Gilmore was working with him on a bit of that. And then written a beautiful build driving script in two parts. We've got a stage 1 part that puts together the change root, the stage 2 part that runs within the change root that drives the build of individual pieces. And so the task then becomes taking the source for those individual pieces, loading them into the change root environment, and gradually building up a library of these sources, along with build recipes that are driven by the stage 2 script. We had a hack session on this just last Friday. Made some reasonable progress, sort of refines the process a bit, took it from something that just DJ had played around with to something that a larger group of people can play around with. Moved it into Git and started to sort of build up the library of packages. Continuing with this next Wednesday. And so this is something that's very much current, something that we're right in the middle of right now. And in fact, I invite you to join us and participate with us. Fairly straightforward to do that. You need an ARM device, or easier yet, a QEMU environment if you've got a reasonably fast x86-64. And needs to be running Fedora 12 or 13. We've got virtual machines that are pre-populated that you can recipes if you want to take that approach. And we're doing work in Fedora on Freenode. We can point you to the URLs and so forth. Rather than give you a stack of URLs, I just want to point you to that channel as a starting point.
You need ARM v7 support.
Yes, sorry. When we say ARM device, it will be an ARM device with v7 support. So the board, Panda board, something along those lines. And any questions or comments?
Are you guys working with Lenario or?
Loosely. We're using some of their tools and they're sort of following us and we're following them and we talk back and forth. But there's not a more formal relationship than that. John, would you add anything to?
Well, so the goal with Lenaro is that they are sort of front organization that represents a lot of interested parties, and so what they do is they upstream stuff. So that's the goal, as we've said to the Lenaro guys, is they work on stuff, they upstream it, and we pull it down. Right? So we may carry a PR patch or two from them, but we're not going to pull their tool chain, for example. So it's not the same as Ubuntu. We're not pulling from them, we're pulling from upstream GCC, for example. They push things into GCC, we pull it back in.
Okay.
Yes.
You see the platform over time becoming a sophisticated collection of build recipes, a little bit similar to Open Embedded.
Well, this is really the bootstrapping process, right? We're trying to get up to the point where we've got our Koji build environment, and from that point we can proceed with the normal Fedora build. So we can take our, whatever it is, 10, 12,000 packages, build them out and get our 15 or 17 or 18,000 binary packages from that. This is the process that we're using to get to the point where we can have that builder and we can take off from there. The build recipes, though, should be reusable. So once we've gone through this, the process of building up for another architecture bumper at a different architecture should be simpler. Any other questions or comments? All right, thank you very much.